Hello, this is Math10150 Lesson 6, and in this video we will talk about linear inequalities in two variables. So first, let's recall what we did so far in the course. We did systems of linear equations. What we did so far, we did systems of linear equations. And for a system of linear equations, we had two lines, and then the solution to that system was a point where they intersect. So the system of linear equations looked like this: ax plus by equals c, and dx plus ey equals f. And each line corresponded to one of the equations, and where they meet, that is the solution to the equation. That was system of linear equations. We also had linear inequality in two variables. We also had linear inequality in two variables. This was a system of linear equations also. We did them in two and in three variables. And for a linear inequality of two variables, it looks like this. It looks like ax plus by and then some greater or less than sign. And the solution to these looked like a half a plane. So what we did with these, we found the line. It was either dashed or dotted, depending on whether it's a strict inequality or not. And then we shaded the side, the half plane, which symbolized, which represented all the solutions for this linear equality. What we're going to do now is we're going to do systems of linear inequalities in two variables. And what does that look like? Well, instead of a system of linear equations, we're going to have a system of linear inequalities. So that's going to look like ax plus b, y less than or greater than or less than or equal to c, and dx plus ey, let's say greater or equal to than f. Though greater or equal to or less than or equal to signs can be anything. And so the solutions for something like this will look like the intersection of two half planes. So we're going to test each one of them and essentially solve a linear inequality in two variables for every one of them. And then we're going to shade the appropriate side for one of them, and then shade the appropriate side for the other one. And then the solution is where they both intersect in this quadrant of a plane. That is the solution. That is the solution set. We're also going to do systems of three linear equations. They're still in two variables, so we're also going to do something that looks like this: ax plus by less than c, dx plus ey less than or equal to f, and we're going to have a third one, gx plus hy greater or equal to then another variable. And solution sets for these can vary, but sometimes they look like triangles in their intersection of three half planes. So let's say we have this one, this linear inequality solution of the first linear inequality, and then let's say we have this one, the solution of the second linear inequality, and then finally we have a third one. And then this final solution is where they all happen to intersect, which is in this kind of triangle. That is the solution set. So these are the kinds of problems that we're going to do in this video. Okay, so let's look at our first problem, our first example of a system of linear inequalities. So we're asked to graph the solution set of the following system: 5x minus y greater or equal to than 5. And the second one in the system is 2y minus x greater than negative 10. So in order for a coordinate point to be a solution of a system of linear inequalities, that coordinate point x1 comma y1 must satisfy both, just like in systems of linear equations. So what are we going to do first? We're going to look at the first equation, the first inequality. We have 5x minus y greater or equal to than 5. Just like when we did linear inequalities of two variables, we're going to look for the corresponding line. The corresponding line is 5x minus y equals 5, and we're going to put that in slope-intercept form because we are interested in graphing it, and then divide everything by -1, and we have 5x minus 5. And let's graph that. So the first line has a y-intercept at -5, and its slope is 5. So it steeply goes up like this, and it is a non-strict inequality, so the line is solid. Now we choose a test point to figure out which side to shade. Our test point could be the origin because it's not on the line. Our test point is 0, 0, and we plug it in and we see that 0 is, and we ask ourselves, is this true? Is 0 greater or equal to than 5? And the answer is no, that is false. So we shade the side of the plane that does not have the test point. Next, we do the second line. The second line, or the second inequality, is 2y minus x greater than -10. We look at the corresponding line, and the corresponding line is 2y minus x equals -10. We put that in slope-intercept format, and we see that the slope is 1/2, and the y-intercept is also -5. So the y-intercept is -5, and the slope is 1/2, so it will have a rise of 1 for a run of 2. and this is a dotted line because this is a strict inequality. And then we also need to figure out which side to shade, so we again choose the test point at the origin because it's not in our line, and we ask ourselves, is 2 times 0 minus 0 greater than negative 10? Is 0 greater than negative 10? This is true. So we shade the side of the plane that contains our test point. And as a result, we have this wedge shape on the plane that is a solution. And so the solution is where the two shaded regions intersect. This is the solution. You can also write a big S in that region that is the solution. That's another common notation. You can also redraw this graph and graph only that triangle wedge piece of the plane that signifies the solution. And so the procedure is similar to solving a system of linear equations with graphing, except there's this extra step of shading the half plane. You can also test your solution by picking any point you can check your solution by picking any point in your solution region and plugging it into both inequalities and verifying that they are true. For our next example, we are going to graph the solution set of the following system. We're going to have 3 now. So the first one is 2x minus 3y less than or equal to 18. The second inequality is x plus 4y less than or equal to 6. And the third inequality is 6x plus y greater or equal to a negative 4. So we're going to solve this system. So we're going to start with the first one, 2x minus 3y less than or equal to 18. Again, we find the corresponding line. The corresponding line is 2x minus 3y equals 18. We put this in slope-intercept format. And we get that the line is y equals 2/3 minus 6. And so we're going to graph that. So the y-intercept is at negative 6, and the slope is 2/3, so for a rise of 2 we have a run of 3. And this is a solid line. Looks something like this. And then we take a test point. Again, the origin is not on our line, so it's a good test point, 0, 0. And we ask ourselves, is 2 times 0 minus 3 times 0 less than or equal to 18? Is 0 less than 18? And the answer is certainly. And so we shade this part of the region that includes our test point. Next, we look at the second line, at the second inequality. This is x plus 4y less than or equal to 6. Again, we look at the corresponding line. Corresponding line is x plus 4y equals 6. We put it in slope-intercept form, minus x plus 6, y equals to negative 1/4 x plus 3/2. So our y-intercept is 3/2, and our slope is negative 1/4. So we have a rise of negative 1 and a fall and a run of 4. And again, this is a less than or equal to, so we draw a straight line. And now again, we take a test point. Our test point can also again be the origin. The reason we always take the origin is that it's always easiest to plug in zeros. So we ask ourselves, is 0 plus 4 times 0 less than or equal to 6? That is 0 less than or equal to 6? This is true. So we shade the part of the plane that contains our test point. Now, if this was a system of 2 linear inequalities, we would be done. We would point to that 1/4 of a plane region that is in the intersection of both of the shaded regions as our solution. But we're not done. We have yet a third. We have a third inequality to consider. So the third inequality is 6x plus y greater or equal to the negative 4. We again look at the corresponding line. Corresponding line is 6x plus y equals negative 4. Putting in slope-intercept form, we get minus 6x minus 4. So the y-intercept is negative 4, and the slope is negative 6. So it's a steep slope that has a rise of negative 6 and a run of 1. And again, it's greater than or equal to, so we draw a line. And again, the origin is not in our test point. The origin is not in our line, so we can use it as a test point. So again, our test point is the origin, and we ask ourselves, is 6 times 0 plus 0 greater or equal to the negative 4? So is 0 greater than negative 4? The answer is no, it is not. So we shade it is 0 is indeed greater than negative 4. And so we shade this part of the plane that contains our test point. And now the three regions are intersected in a triangle. And so the solution to this system of 3 linear inequalities is this triangle, and we can also label it with an S to signify that this is the region that's our solution. You can always take a point from this region and plug it into each of the three inequalities just to double check that it is indeed the solution.